Hey folks, welcome to today's lesson. We're looking at sketching regions. In order to do this, I'm going to start looking at two particular questions. The first is y is greater than 4, and I'm going to look at y is less than x plus 1. Okay, so in order to graph these ones, basically what we need to be doing is looking at simply graphing the function of y equals 4, or graphing the function y equals x plus 1, and then we need to shade the region that suits this inequality. So first of all, hopefully by now actually we should be able to sketch our functions pretty quickly. This is the line of y is equal to 4, so hopefully we know that that goes through the y-intercept of 4 and it goes straight across. Now if this was y was greater than or equal to 4, I would make this line a full coloured in line, like a full block line. But in this case, because it's y is greater than 4, it's good practice to do a dotted line here. Once we've actually graphed that line y equals 4, I'm then going to test the points to see whether or not the function works for a particular side. Because basically what we're going to be doing is either shading less than underneath it, or we're going to shade greater than above it. So how do we know? Well, you probably look at this and go, okay, well it's going to be greater than 4, so we're probably going to be colouring in all that kind of section or shading that section above, because that's when y is greater than 4, and that's not a bad way of doing things. But a really good practice is to take a point, and often the origin is the best one to use because that's point 0, 0, and we can test it in our function to work out if it's true or false. For example, if I put the 0 where the y is 0 greater than 4? No, it's not. That's false. Therefore, it's the other side that we need to shade, and that can be similar to what we've done already. If I wanted to graph y is less than x plus 1, what I'm going to do is sketch the function of y equals x plus 1. That means I've got a y-intercept of 1, and if I put the 0 where the y is and rearrange it, we can get our x-intercept of negative 1. And it's less than again, so I'm going to do a dotted line, and that's my line of y equals x plus 1. Now, again, you might think, oh, it's going to be less than, so it's probably going to be underneath the line, not above the line. But again, a good practice will be to test the points. Again, you can see that 0, 0 is clearly on one side of the line. So I'm going to test that and put 0 is less than 0 plus 1. So that means 0 is less than 1. That is true, therefore that part needs to be shaded. So again, the whole idea is, first of all, we want to graph the function. Second of all, test a point. And thirdly, we're going to shade the region. And sometimes you might have more than one function that you're doing it for, and they might overlap. Okay, let's have a look at a question now. Sketch the region bound by y is greater than x squared and y is less than 5. So here we're going to be actually sketching two functions on the one axis, and we want to look at where the shading satisfies for both of them. Okay, so I'm going to start off by, first of all, sketching the function y equals x squared, and again, hopefully we know that's just going to be a nice parabola. So that's y equals x squared, and we've got y is less than 5, so I might choose a different color. So again, I might put that as 5, and I'm going to put my line there. They're my two graphs. Now most likely you're probably going to think it's going to be shaded underneath in here, but let's just double check that. So if I test y is greater than x squared, I'm not going to choose 0, 0 to test the point, because that's actually on that parabola line. So I'm going to maybe test, let's say, this point here, which is the point 0, 3. So the x value is 0, the y value is 3. 3 is greater than 0 squared. That is in fact true. Therefore, for my parabola, we're kind of shading all this part inside here. Okay, my next part we've got is y is less than 5. This time I am going to choose 0, 0. 0 is less than 5. That's true. Therefore, I'm shading underneath the actual graph, which means that you can see clearly that the area shaded is actually between these two lines. Now notice that I don't want to go below the red parabola line because we know that's not being shaded. We've already tested that part. And you can see the above bit, we don't actually need any of that shading there. Often what you can do when you're doing this, you can do each inequality on its own and then shade just different directions, and you can see the one that's been shaded mostly, or you can rub out your marks and just leave what's satisfied. Okay, next question. We've got sketch the region x squared plus y squared is less than 0. So we know that's a circle. We should know at this point that the circle has a center of 0, 0, and we have a radius of 0. And that's not going to work, is it? So I'm just going to change that. I'm not sure where that question came from. I'm going to change it to 4. So we've got a radius in this case of 2. So I'm going to now plot my graph, so my y, my x-axis. We can see we've got a radius of 2, so I'm just going to put -2, +2, +2, and -2, and we're going to sketch that circle. So it's not really perfect, but it's not too bad either. Okay, so that's my circle of x squared plus y squared equals 4. So now I need to figure out when I need to shade it. Again, you've got the origin 0, 0 that's clearly on one side of that line. So I'm going to test that. So 0 squared plus 0 squared is less than 4. And that is true. 0 is less than 4. Therefore, I'm shading all inside here. That's it. The last one we're going to do is going to be a 3-bounded question where we're going to have, again, one axis, and this time I'm going to have 3 different graphs. I might do this as if I was doing it in my book to show you what I mean by the different sort of angles of shading. So first of all, we've got 3 graphs. We've got y equals 2 to the power of x. Okay, now y equals 2 to the power of x is an exponential graph, which looks something like this. And that point there, hopefully we know, is 1 because I sub in x equals 0. That's positive 1. We've got the graph of x is greater than -2. Okay, well -2, I'll put this one in purple maybe. So -2, that's -1, -2. Okay, I'm going to use this line here. That's a line of x equals 2. And then we've got y equals, this one in white, y equals 4. So I'm going to put that one up here. And so most likely with these questions you can probably see that the area that's bound by those 3 curves is probably going to be sort of that area inside there. But again, we don't want to judge things in case we could be incorrect. So I'm going to now shade this. So I'm going to start with the first one I did. Y equals 2 to the power of x, or greater than 2 to the power of x. I'm going to put 0 in here, the point 0, 0. So we've got for this one, 0 is greater than 2 to the power of 1, which is 2 to the power of 0, sorry, which is 1. And that is false. So for this one, I'm going to be shading all above that line. The next one we're going to look at is the purple line, which is x is greater than -2. So x is greater than -2. Once again, 0, 0 is nicely on one side of it. So I'm going to put 0 is greater than -2. And that is true. Therefore, I'm going to be shading this section of my graph. Now what you probably can see is a lot of people probably wouldn't shade underneath here because we know on exponential that that part of it's not included. But what I'm trying to point out, you can start seeing this cross pattern that I'm developing where the shaded region is bound by more than one line. The last one we've got is y is less than 4. So again, if I put 0, 0, 0 is less than 4, that's also correct. And I might use a slanted line. And what you can then see is that you've got this section inside here that's bound by all 3. So again, some people might then get a rubber and rub out all the other shadings, okay, or just make it very much well pronounced like I've done there. Again, guys, this is shading regions. I hope this made a little bit of sense to you. Any questions, please ask. But certainly do a few questions on your own and make sure you can do this stuff. Have an awesome day, folks. Enjoy.